Good morning everybody. Welcome to my channel The Proper Guidance. Here we are today to discuss about the chapter number 5 of class 12 computer science, and this is about sorting technique in computer science. Okay, so in this chapter we will learn bubble sort, selection sort, insertion sort and time complexity of algorithms. This is a very important chapter and all these techniques are very useful in programming language, especially for data structure concept. And these are the sorting techniques, how to arranging the ordering, to the process of ordering of arranging a given collection of elements in some particular order. So this is very conceptual thing. You have to learn it in a conceptual way. Please listen the class minutely and be patient when you are listening this class. Okay, so first introductory part, introduction. Sorting is the process of ordering of arranging a given collection of elements in some particular order. We can sort a collection of numbers in ascending or descending order. This is the very basic point, that when you are arranging something, either you will arrange it in an ascending order or in a descending order. That is either in increasing way or in decreasing way, and that's the order we can arrange it properly, right? So if the collection is of strings, we can sort it in an alphabetical order. If there is a string, we have to sort it in an alphabetical order, that is A, B, C, D, like this up to Z, or from Z to A in the reverse order of characters in the English alphabet, right? So this is for string, or according to the length of the string. Okay, for example, words in a dictionary are sorted in an alphabetical order. Seats in an examination hall are ordered according to candidates' roll number. We can also sort list of students based on their height or weight. Imagine finding the meaning of a word from a dictionary that is not ordered. We will have to search for the word on each page till we find the word, which will be very tedious. That is why dictionaries have the words in alphabetical order, and it is the process of searching. Okay, so sorting a large number of items can take a substantial amount of time. However, this extra time called overhead is worth when compared to the amount of time needed to find an element from an unsorted list. Sorting is an important area of study in computer science. This is very important topic. Okay, and many sorting algorithms have been developed and analyzed from their performance point of view. In this chapter, we will learn about three sorting methods. We will learn that implement them using Python. Bubble sort is discussed in section 5.2, followed by discussion on selection sort and insertion sort. Okay, so the first topic is bubble sort. The first sorting technique we are going to understand is bubble sort. Okay, this is the first technique. It sorts a given list of elements by repeatedly comparing the adjacent elements and swapping them if they are unordered. Okay, so what I am telling, that it arranges all the elements in a given list by repeatedly comparing the adjacent elements and swapping them if they are unordered. Suppose there are some given numbers in an array or list of array, that is 5, 4, 3, 2, 1. Now 5, 4, 3, 2, 1, it is already ordered because this is in an decreasing way, right? 5 is greater than 4 and 4 is greater than 3, 3 is greater than 2 and 2 is greater than 1. So this is the sorted, already this is sorted, already this is in an ordered list. So we need not to sort anything. But if there are some given integers like that, 5, 6, 1, 4, 7, 8, like this. Then we have to order the given list in such a manner that if I arrange it in an increasing way, then we have to first take the small elements, after that followed by the greater elements, right? Larger elements will be followed after the smaller one. This is one way, and the other way is in a decreasing way, that is from the greater number to the lowest number, smallest number. Okay, so this is the very basic concept of how to order a list, right? And when we are doing something, suppose in your study room, you have so many books and copies and all those things are there, and if you have to arrange those books, first you take the bigger one and then the smaller one by one, in a very beautiful way you will arrange it on your table, right? And this is done, and this will be done in also the data structure for the elements in the computer also. This is the technique. And what is the technique? When you are keeping the books, you just take two books, right? Two books, this is the larger one, okay, so I put it in the, put it first, after that the smaller one on the bigger one, right? One by one. There are so many lots of books. We are taking all the books and taking, and then just comparing them, and we will place them in a ordered way. Okay, and this is also followed for bubble sort in the elements in the data structure also. So it sorts a given list of elements by repeatedly comparing the adjacent elements and swapping them if they are unordered. The technique is very simple. First we will read the notes here. After that there is a example. There is an example, and I will go through the complete example with the proper explanation. Okay. So listen it. Swapping into elements means changing their position. Swapping two elements means changing their positions with each other. Okay. So this is the very basic meaning of swapping, changing their positions with each other. Okay. So in algorithm, every iteration through each element of a list is called a pass. This is also a new term for you, that in algorithm every iteration through each element of a list is called a pass. For a list with n elements, the bubble sort makes a total n-1 passes to sort the list. This is a very important point in this chapter, that the bubble sort makes a total of n-1 passes to sort the element when the number of elements will be n. Okay. In each pass, the required pairs of adjacent elements of the list will be compared. In order to arrange elements in ascending order, the largest element is identified after each pass and placed at the correct position in the list. This can be considered as the largest element being bubbled up. Okay, hence the name bubble sort. The name indicates that what is bubble sort is actually happening in the sorting algorithm. This sorted element is not considered in the remaining passes, and thus the list of elements gets reduced in successive passes. Here is a figure demonstrating the working of the bubble sort method to arrange a list in ascending order. Let us consider a list having 6 elements. This is an example, okay? This is an example, and we will see it in a figure below. In the figure, elements being compared are highlighted with blue color and sorted elements, and this, okay, just go to the picture here. Num list index, 6 numbers are here. When there are 6 numbers, the first index will be 0, starting from 0, and there are 6 elements, so the indices will be 0, 1, 2, 3, 4 and 5, from 0 to 5. And the given numbers are like this: 8, 7, 13, 1, -9 and 4. These are the given numbers in the list. Now, comparison in pass 1. What is the actual definition of bubble sort? We have to take 2 adjacent numbers and we will compare them. Then after that we will swap if they are in unordered way. Okay, so we are setting this given array in an increased way. Okay, increased way means smaller one will become first, after that the greater one. Like this we will arrange the given list. Now here is the picture. In the blue box you can see here there are two numbers 8 and 7, the first two numbers, right? Now 8 is greater than 7 or not? Yeah, 8 is greater than 7 obviously, and 7 is smaller than 8. Then we have to change their positions. In this word, the word is used here, swapping. Okay, change the position of 7 and 8 because they are in an unordered way. 7 is smaller than 8, so we just change their places, interchange their places. See here, all the remaining elements will be same here. 13, 1, minus 9 and 4 will be remain still. After that we change 8 and 7 their positions, and 7 and 8 we will find the first two terms as 7 and 8. After that 13, 1, minus 9 and 4. Next 7, 8, 13, 1. Now see, first we checked the first two terms. After that these 7 and 8 are already checked and interchanged their places. After that second two terms 13 and 1 will be taken as the pair and they will be compared. Now 13 and 1, which one is greater? 13 is greater. So again we have to change their positions, and in the next term you can see here 1 and 13 is changed, minus 9 and 4 remain unchanged in that particular list. So we now get it 7, 8, 1, 13, minus 9 and 4. Now see, these two terms will be now checked. Which two terms? One by one we have to take the terms. First terms 13 and 1 checked. After that we will check. Actually you will see the indices 0, 1, when index 0, index 1 was checked. After that number 1 index and index number 2 are checked. After that index 2, index 3 have checked. After that index 3 and 4 will be checked. When we are checking those elements in the index number 3 and 4, we get 13 and minus 9. And which one is greater? Obviously 13 is greater. So again there is an in position interchanging and swapping system happened here, and minus 9 after 13 and then 4. And the last checking 13 and 4, 4 is smaller than 13, so 4 and 13. We get this ultimate list like this: 7, 8, 1, minus 9, 4 and 13. Now see, this is comparison in pass 1. Now what is pass? What is pass? We have just go through that particular section, that what is pass. What do you mean by pass? In algorithm, every iteration through each element of a list is called a pass. Every iteration, each and every iteration is known as a pass. The first pass, in this first pass, comparison in pass 1, we get this one. Okay, this is for pass 1. Next, the same mechanism will be happen for comparison in pass 2. Now see here, comparison in pass 2, first two terms 7 and 8, we are comparing this one. 7 is smaller than 8, so let it be there, no problem. Next 8 and 1 will be checked. Next two indices, elements of the next two indices will be checked. 8 and 1, 1 is smaller than 8, change the position. 1, 8, 7, 1, 8. After that 8 and minus 9 will be checked in the blue box. Okay, look at the picture here. 8 and minus 9 will be checked. Minus 9 is smaller than 8, so interchange the position. Next we have to check 8, 4 and 8. 4 is smaller than 8, no problem, and 8 is also smaller than 13. So this is in this comparison in pass 2, we get the resultant list like this one. Next, comparison in pass 3. Now check it. 7 and 1, 1 is smaller, so swap them. 1, 7, minus 9, 4 like this. Again 7, 9, minus 9 is smaller, swap them. Again 4 and 7, 4 is smaller than 7, so swap them. Now see, 7, 8, 13, they are in the ordered way. So next comparison is pass 4. we will check 1 minus 9. Minus 9 is smaller than 1 because this is a negative number and 1 is obviously positive number. So minus 9, swap them, minus 9 and 1. After that 1 and 4 is checked, 1, 4, no change. No change, and the remaining part 7, 8, 13, they are already in an ordered way in comparison in past 3. So now we get the resultant list elements in the list in an ordered way, that is in an increased order, right? Ascending order, we can see here that minus 9, 1, 4, 7, 8, 13. They are following the ascending way, okay, ascending order. So this is the bubble sort technique. I think you can understand it properly. This is the mechanism, and after that comparison in past 5, when in past 5 minus 9, 1 unchanged because minus 9 is smaller than 1. Now so algorithm 5.1 shows the steps followed for the bubble sort that takes num list as a list of n elements and sorts the list in ascending order. Here we can see the mechanism in an diagrammatical way. This is the main concept. You have to first realize what actually happens through this diagram. After that we will learn the programming part, how to write down this one. How to write down this one? This is the algorithm for bubble sort. This is very important. You people please go through bubble sort num list n. Here is a list. Step 1, set I equals to 0. Step 2, while I less than n, repeat steps 3 to 8 when I less than n. Now set j equals to 0. Step 3. Step 4, while j less than n minus I minus 1, repeat steps 5 and 7. What are the steps? What are those steps? So if num list j greater than num list j plus 1, then swap num list j plus 1. What I have told you, that we have checked the indices one by one, and when you check according to the index number, you are checking not the index number, you are checking the elements existing in that particular position, okay, because index are in an ordered way, 0, 1, 2, 3, 4, 5, but particular in that position, in that indices, which elements are there and how they are ordered. This is our concept, and we have to order them properly. The elements should be arranged in an ordered way, and for this thing we are following here bubble sort technique. This technique is completely explained in this diagram, okay. So this is clear to you. Next, set j equals to j plus 1 and set I equals to I plus 1. You people do one thing, you just write down this complete algorithm in your copy and then check what it happens for the previous picture. The given algorithm, the given example is here num list. Num list will be 7, 8, 13, 1, minus 9, 4, just like this. And what will happen, you can see through the programming part. Clear? Now, this is the algorithm. Algorithm means what are the steps you have to done. This is known from an algorithm, and program means you have to implement all those steps through the programming syntax. We here learn the Python programming language, so you have to follow the rules of Python to implement the particular algorithm structure in this Python syntax. What we have to do? See here, implementation of bubble sort using Python. Def bubble sort list n list 1 for I in range n, for j in range 0, n minus I minus 1, size I minus, because last I elements are already sorted in previous passes. If list, now there is an if list, swap them like this, num list bubble sort. Clear? So this is our program. Now you have to print the sorted list here. For I in range this one, print this thing. and output is here. Okay, so this is the entire program for BUBBLESORT. This is very, very important. If you face any problem to understand this one, please feel free to ask me. I will clarify again. Okay, next we will learn selection sort. Okay, one more thing is that there are different techniques. These are the techniques, right? Where to follow BUBBLESORT, when to follow selection sort, this will depend on the situation of the program. Okay, when you just clarify all the differences of different techniques, you can easily understand where to apply BUBBLESORT technique, where to apply selection sort, or where to insertion sort. So next we will learn selection sort. See, selection sort is another sorting technique to sort a list having L elements. Here are also L elements. The selection sort makes n-1 number of passes through the list. The list is considered to be divided into two lists. The left list containing the sorted elements and the right list containing the unsorted elements. Initially, the left list is empty and the right list contains all the elements. Clear? Initially, the left list is empty and the right list contains all the elements. For arranging elements in ascending order, in the first pass, all the elements in the unsorted list are traversed to find the smallest element. The smallest element is then swapped with the leftmost element of the unsorted list. This element occupies the first position in the sorted list and it is not considered in further passes. Clear? What it happened? For arranging elements in ascending order, in the first pass, all the elements in unsorted list are traversed to find the smallest element. All of them are going to find the smallest one. The smallest element is captured and swapped with the leftmost element of the unsorted list and make it fixed there. Okay, in the first position, and it is not considered in further passes. We will not consider because we know that this is the smallest one, so need not to check further for the particular number. Then the remaining portion in second pass, what will happen? The next smallest element is selected from the remaining elements in the unsorted list and swapped with the leftmost element of the unsorted list. Okay, not the first position. From the second position it will be considered, and where is the smallest number here? And for the given list, that would be the second smallest number, but for the remaining list, that would be the smallest number. It will find all the numbers, will go and find for the smallest one. It will take from there and fix them in the second pass. It will fix it in the first position, and this first position is the second position of the given list, that is index number 1. From 0 it will be start 0, 1, 2, 3 like this. So this is the position number 1, index number 1. It will be fixed there, and these two terms will be fixed, and after that the remaining section, this mechanism will continue. This process continues until n-1 smallest elements are found and moved to their respective places. Clear? The nth element in the last, and it is already in place, so we need not to take any action here. So here is another figure to demonstrate this. We will see it. Look at that example. Same thing, num list, the given list is same. The index 0, 1, 2, 3, 4 and 5. Now the elements are here 8, 7, 13, 1, minus 9 and 4. We are doing here selection sort. The name implies we have to select. Okay, we have to select. Now see, in this given numbers, which one is the smallest one? Obviously minus 9. We can see it. It is the smallest one. So comparison in pass 1. What will happen? Look, 8, blue box, 8, it is checked with 7. When it checked with 7, after that 7 and 13, after that 13, 7, 13, 1, 1, minus 9, 4. it gets the smallest number -9, and when it gets the smallest number -9, it will swap to the leftmost index position, and -9 will be fixed here. In index number 0, this element is fixed, and for the next pass, this remaining section from index number 1 to index number 5, this will be considered, and this green box will not be considered. This is fixed. Clear? Now, comparison in pass 2. When for comparison in pass 2, we are marking when the first comparison is started, now it is marked with blue box, and my green box will be remain same. This is fixed position because it is already sorted in this manner. Now see, 8, 7 checked, 7, 13 checked, 7, 1 checked, 1, 4. All the elements are going to check which is the smallest number here, and it is found that 1 is the smallest number here. To swap it from its position to the leftmost position, that is index number 1 here. So 1 and 8 are swapping in their position, we get 1, and now -9 as well as 1 will be fixed. The remaining section with the dotted line sections from index number 2 to index number 5 will be considered for comparison in pass 3. We will consider from index number 2 here, blue box. Now 7, 13, 7 is smaller, 7, 13, 7, 8, 7, 4, we will get 4 is the smallest one in this particular list. So swap them, and 4 is again here in the leftmost part of the particular section, and we will now get 3 green boxes. This part is fixed here. Now the same mechanism will be observed for the remaining portion, that is 13, 8 and 7. Comparison in pass 4, we will check 13, 8, 7. 7 is the smallest one, let it be there, 7 in green box, and 8, 13 is remaining here. Now see, comparison in pass 5, 8, 13, 8, 13, 8, 8 is smaller than 13, so need not to swap anything. Okay, now we get the list completely in green box, right? -9, 1, 4, 7, 8, 13, and this is in an ascending order. So this is the mechanism of selection sort, and this is done very clearly with the help of this diagram. You people please go through. The following is an algorithm for the selection sort that takes num list as a list consisting n elements and sorts the list in ascending order. Now algorithm selection sort, same thing, selection sort num list n, step 1 set I equals to 0, while I is then n, repeat step 3 to 11, min, set min equals to I and flag equals to 0, set j equals to I plus 1, step 5, while j less than n, repeat steps 6 to 10. If num list j less than num list min, then min equals to j, flag equals to 1. If flag equals to 1, then swap num list I, num list min, set I plus 1. So this is the algorithm for selection sort. Now what to do? Now we will implement this particular algorithm for Python programming language. Okay, and here is the program code snippet. You people please go through. This is very important, and along with this we also get here the output, and if there is any problem to understand, please feel free to ask me. I will explain with the help of a board work. Actually, today we were learning from NCERT study material, and this is completely a theory class. If people have any query about sorting algorithm or anything, please ask me. I will arrange another class for you. Okay? So today's last topic, I think this is insertion sort. This is a different technique. Maybe the techniques are different, but the purpose is same. What is the purpose? We have to arrange the given list. Okay, so let's start. Insertion sort is another sorting algorithm that can arrange elements of a given list in ascending or descending order. Like selection sort, in insertion sort, the list is divided into two parts, one of sorted elements and another of unsorted elements. Each element in the unsorted list is considered one by one and is inserted into the sorted list at its appropriate position. In each pass, the sorted list is traversed from the backward direction to find the position where the unsorted element could be inserted. Hence, the sorting method is called insertion sort. We have to insert the particular element to its particular place. In pass 1, the unsorted list has n-1 elements and the sorted list has a single element, say element S. Now, the first element of the unsorted list, say element E, is compared with the element S of sorted list. If element E is smaller than element S, then element S is shifted to the right, making space for inserting element E. This shifting of list size n-2. Now, in pass 2, the first element, say element E, unsorted list, starting and doing the mechanism again and again. Now see, this is the example, and with the help of a diagram you can understand it properly. Num list, same list is given here. Index will are the same from 0 to 5, and the given numbers, given elements are also same here, 8, 7, 13, 1, -9 and 4. Now comparison in pass 1. What will happen here? Look at the picture. 8 in the blue box. 8, 7, 13, 1, -9 and 4. 8, 7. 7 is smaller, swap it. 7, 8. Comparison number 2. 7, 8, 13. 8 is smaller than 13, so need not to change. No changes here. 7, 8, 13. This is pass number 2. Now comparison in pass 3. 13, 1. 1 is smaller. 1, 8. Again 1 is smaller than 8 also. From 13 also and 8 also. So swap it. 1 is here. Again 1 and 7. Swap it. 1 is smaller. So this is comparison in pass 3. Now comparison in pass 4. 1, 7, 8, 13. 13 minus 9. Minus 9 is smaller. Minus 9 is smaller than 8 also. From 7 also. From 1 also. So put it here. Minus 9, 1, 7, 8, 13 and 4. Comparison in pass 5. 4, 4, 13. Swap it. 4, swap it. 4, 8. 4 is smaller. Again 4, 7. 4 is smaller than 7. Again 4. Now no change. 1, 4. 1 is smaller than 4. It's okay. So minus 9, 1, 4, 7, 8 and 13. So we get the ordered list. So comparisons done in different passes of insertion sort. We have to insert the element in the proper place. Let us consider that num list is a list consisting of n elements, and algorithm is here for insertion sort. Same thing, go through step by step. If any problem arises, let me know. And implementation again of insertion sort using Python along with the output. Okay, so these are the three techniques we have learned today, that is bubble sort, insertion sort, and which one? First one we learn here bubble sort technique. After that we learn selection sort, and then we learn insertion sort. Next topic in this chapter that is followed, which one is followed here? See, time complexity of algorithm. Now see, what is time complexity of algorithms? This is very important concept of data structure. Listen, we have studied that there can be more than one approach to solve a problem using a computer. Yes or no? Yes. In class 11, we compared 4 different algorithms to check whether a given number is prime or not. For very simple example, in real life, I am telling you that when you are going to somewhere, suppose you have to go to your school or college, and you may take the rail route, you may take bus route, you may take walking route. Okay, there are so many routes are here. Which route you will consider? You will consider the most convenient route for you, no? That is, if it is of less cost, you have to pay a little amount, then you will consider that one also. Again, if it is very time consuming, you may avoid that particular route because time is very important. So there are different matters, different things we have to think, and this is the thing also considered in computer science and data structure also. There are so many algorithms to order up the list, but which algorithm is applicable in which condition, in which situation, you have to consider it with the help of complexity of algorithm. We have to calculate the complexity of algorithm. The complexity of algorithm helps you to select the appropriate technique or appropriate algorithm to implement in that particular programming section. This is the concept of time complexity of algorithm. Now see, in class 11, we compared 4 different algorithms to check whether a given number is prime or not. For the same problem, one algorithm may require more processing time than the other. The amount of time an algorithm takes to process a given data can be called its time complexity for a small set of data elements shown in examples of this chapter so far. The time and memory required by different algorithms do not differ significantly. However, in the real world, sorting algorithms are required to work on huge amounts of data, what I am just telling you. In such cases, the total time utilization becomes significant, right? The most important thing is time. So, total time utilization becomes significant, and therefore, it is important to consider the time complexity of an algorithm before being used in a real world data set. When you are going to implement something in real world data set, you have to first check the time complexity. Computer scientists proposing different techniques for sorting are always inserted to find out their time complexity. The main aim is to find out how a sorting algorithm behaves if the order of input elements changes or if the number of elements in the list increases or decreases. Such comparisons help to decide which algorithm is more suitable for which kind of data and application. Okay, so calculating the complexity of different algorithms involves mathematical calculations and detailed analysis, and it is beyond the scope of this textbook to discuss them in detail. However, we will discuss some basics of complexity to get some ideas. The following tips will guide us in estimating the time complexity of an algorithm. Any algorithm that does not have any loop will have time complexity as 1. Since the number of instructions to be executed will be constant irrespective of the data size. Such algorithms are known as constant time algorithms. Clear? What I have told, that any algorithm that does not have any loop will have time complexity as 1, since the number of instructions to be executed, whatever may be the number of instructions, it will be executed will be constant, and irrespective of the data size, whatever may be the size of data, it will be executed, it will be to be executed will be constant terms. Such algorithms are known as constant time algorithms. Clear? This is one type of algorithm. Next, any algorithm that has a loop, usually 1 to n, will have the time complexity as n, because the loop will execute the statement inside its body n number of times, right? Such algorithms are known as linear time algorithms. Clear? This is another type of algorithms. First one is constant time algorithm. Next one is linear time algorithm. Next, a loop within a loop. Nested loop concept, we have done it. Nested loop will have the time complexity as n square. Such algorithms are known as quadratic time algorithms, because n square, you can see here, quadratic equation may be there, and so it is known as quadratic time algorithms. The name implies that there should be some n square terms like this. Okay, so this is quadratic time algorithms. If there is, next one, if there is a nested loop and also a single loop, both loops are here, nested also and a single also, the time complexity will be estimated on the basis of the nested loop only. When there are both of them, the nested loop and single loop, the time complexity will be estimated on the basis of the nested loop only. Now, look at the Python programs of the 3 sorting techniques discussed in this chapter. You will notice that in each of the 3 programs there is a nested loop, that is one inside another. So, according to the above rules, all the sorting algorithms, namely bubble sort, selection sort and insertion sort, have a time complexity of n squared. The last line is very important to you. This is also important for short type of questions also, and this is very basic concept. When you people go through the, for any of you, if you go for computer science subject in further your higher studies, it will be very helpful. This is the basic concept, and you have to do a very clear concept in this section about type complexity, because all the important things for programming language will depend on this particular thing. And for real life data section, when we implement something, then this is the very important section to look about, that what is the time algorithm, what is the time complexity here. After that only it is considered that whether this is taken or not. Okay, so today we have completed this chapter number 5, which is all about sorting technique. Okay, so you people please go through all the important thing I have discussed today. Maybe the class is lengthy, but I think this will be helpful for you. So next day we will meet and learn about chapter number 6. Till then, take care and thank you for watching.